Hi everyone, welcome back to China Manufacturing Decoded from Sofeast. Adrian from the team on hosting duty today, and I'm joined by our head of new product development, Andrew Amirnovin, once again. Andrew, hi, welcome back.
Adrian, good to be here. So today we are going to talk about DFR, I take it?
Yeah, we are. Design for reliability is today's topic. And I mean, you've spoken about DFR. Well, you've spoken about product reliability on a few podcasts, and I'll link to those in the show notes of this episode. But with a particular focus on design for reliability today, I think what we're trying to get at is really to give the listeners a good understanding of why product reliability is so important and how we actually get to that point of having a very reliable product once it's hitting the shelves and selling. You know, what's the process? And I think DFR is something that a lot of importers who are designing and developing a new product to bring to market, that's something that they absolutely need to be including in the overall project, right?
Yeah, absolutely. I think that we've discussed before what reliability is, and we've kind of went a little bit more in detail, but we haven't in detail talk about what is design for reliability. Design for reliability comes from, I believe it's an ASQ, American Society of Quality, terminology for DFX, design for excellence. Maybe it also comes from ISO requirements, but really design for excellence. One of the components is design for reliability. For example, design for manufacturability, design for testing, design for assembly. And one of the components is design for reliability. And design for reliability has a lot of little, let's say, components to itself in order to actually design a product for reliability. Well, let's put it this way. There's the main objective, right? And the main objective is to reduce cost by improving the quality and reliability of the product. That's the main objective of design for reliability. And I think that is the key that a lot of people forget when they're designing a product.
Mm-hmm. Yeah, I like that you've mentioned DFX. So it's a number of different approaches that we can take when we are designing a product. And it's kind of like a focus on these different aspects, right? And I suppose when you're designing a new product, you're going to focus on a number of things. It might be design for reliability, but it could also be for manufacturability and a number of the other points that you've mentioned. So with that focus on the aspect of reliability, I also like that you've just talked about the main objectives of what this is.
Right.
Do you have any other points about the main objectives?
Well, I think if you translate what that main objectives really stand for, reducing cost by improving quality and reliability. If you translate that, really it means you kind of need to make the whole product reliable. And the whole product consists of what? Consists of parts, consists of design, consists of testing, analysis of the data, a whole bunch of things that you really have to do it right to be able to make the product reliable and at the end of the day, save costs.
Yeah, absolutely. A number of times, actually, we've spoken about the cost of poor reliability, which I'm sure is a phrase that the listeners have heard before, right? And also cost of poor quality, I think, is kind of related to that as well. So I see where you're going with this. It probably makes sense at this point then to talk about unreliable products, right? And this is what we're trying to avoid. And so when we're trying to understand the importance of product reliability, looking at the bad outcomes is probably a good way to understand why it's important, right? So what makes a product unreliable? There are quite a few different items, right?
Yeah, there are a lot of reasons why a product become unreliable. Before we get into that, let me mention something that I
Okay.
think a lot of our listeners and readers can actually relate to that. When I was in college, I used to have a Toyota Tercel. It was a really small, little car. And honestly, I used to do all the repairs, oil change, and everything myself. And it was a very uncomplicated car. If something broke, all I had to do, look up on the user manual what's not working. It would tell me what's probably the problem is. And I'd go to automotive shop in US. There was one called Pep Boys. They were pretty good at, pinpointing, if you told them what the symptoms were, they were pretty good at pinpointing what the cause was. And they gave me the right part, and I'd just have to go back with a screwdriver and maybe a plier or something, and I would just replace the part, and everything was fine and dandy. Move on and use the car again. But in today's automotive, they have gotten a lot more sophisticated. There are more wires and cable. There are more electronics, especially the ones that are battery operated. They're not like the old cars where there's no pistons, there's no motor, and all the motors are electrical, and it really makes it a lot more sophisticated when something goes wrong. And in today's world, the more parts you have, right, the more unreliable a product will be. If you got only one part to test, then it's pretty easy. But if you got 100 parts, any one of those 100 parts can go wrong and can create a defect that can really, really complicate. But let me just say, if you had, for example, unreliable design to start with, that could just make the whole thing, very complicated. Because if you got unreliable design that is not meeting the design guidelines for that type of product, then you could fail, for example, compliance test. You could fail certain temperature requirement, like, for example, the product could overheat, catch on fire, or it could not perform to the specification that you designed for. And so there could be all kinds of issues just because it's just not a very good design. And then the same way, if you bought cheap parts, that the kind of parts that were not tested to your particular product requirements. Let's say you're trying to design a product that is supposed to last for 5 years and is supposed to operate in the hottest part of Earth, like Amazon, with high humidity, high temperature. And then it's supposed to operate in the coldest region of the world, like Alaska, minus 40 degrees zero, very, very cold temperatures. And if you accidentally or knowingly, you went and bought parts that don't really meet these environmental conditions, reliability, stress requirements, then most likely you're going to have some of these parts actually fail right in these environments, when it gets too hot, or when it gets too cold, when it gets too humid, or there is too much vibration going on, you're going to fail these components. So component quality and reliability is just as important for overall product reliability as for the whole thing. So I think a lot of times, people might, those entrepreneurs that are new in this area, they may kind of discount component reliability, and they might say, well, we'll just design any kind of a component. It's fine. It'll work. Yeah, it might work, but it may not work for long. And that's one of the important things that you need to consider.
Another thing was the shipping. You mentioned vibration, right? And that just reminds me, because recently we spoke and wrote about Easter 2A testing, which is the transportation testing. That was me and you. And you spoke about how important it is to test your shipping cartons to be able to handle, common vibration and the different heat changes and things like that. And of course, these are going to affect the products and the components inside the products, which might have been fine up until, they got vibrated for 3 months when they were being delivered across the ocean or whatever, or 2 months. And then they fail. Then you've got unreliable products. So that reminded me of that recent topic that we covered.
Yeah, you're absolutely correct. ISTA 2A has a whole series of tests that has to do with package drop, vibration, temperature, humidity, and the whole thing actually helps to determine whether or not your package is durable enough that can contain your product inside the package in all good condition until it reaches its destination. And as you mentioned, this is extremely important, because if you don't have very good packaging, then the vibration could act, and all the other kind of stresses during the shipping could actually impact the product itself. Maybe the package will break and the humidity will seep into the actual products one by one, and could cause all kinds of mayhem at the end when your end user receives the product. But one of the other things that I know for sure that really impacts the reliability is reliability testing, and not only hardware reliability testing, but also software reliability. A lot of people forget that software reliability is just as important as hardware reliability. If you have a product that heavily involved in software use, and all of a sudden somewhere in the middle you end up having loops that causes software to not function and crash, and you can't use the product, right? And I think that testing in general, whether it's software test, hardware test, in terms of reliability test, or component test even, and even during the assembly, you got final test. This testing, the entire testing process, for no matter what stage of the development it is, needs to be done correctly, need to be done decisively, need to be done in a way that actually never going to fail. And that's very, very important. And the other thing that I think a lot of people forget is that, okay, you did your testing, right? And you got a whole bunch of data. Well, you got to know how to do Pareto analysis on your data. You need to know, what percentage of your data failed, what percentage passed, what percentage was borderline, and you need to have some kind of an action plan for each one of those areas. Well, what are you going to do with the data that passed? What are you going to do with the ones that are borderline? And what are you going to do with the ones that failed? You need to have an action plan for each. And if you don't analyze those correctly and don't implement the proper corrective action for each area, you basically you'll keep getting field failures, and you wouldn't know exactly how to fix and how to going to handle on your returns.
Yeah. I'm kind of struck by how wide-ranging this is. So we're talking everything from component level testing for individual components all the way through to even your shipping cartons, and all of this feeds into product reliability. So clearly it's very, very important. And you're talking about some of the things that we don't want to be forgetting. So that's to get all that data together and then come up with an action plan, for example. And that kind of leads me into the next question, which is, we're talking about, the actual bringing the product to market as well. And that's going to include manufacturing as well, right? So manufacturing also is likely to have an impact on reliability.
Absolutely. Adrian, manufacturing is probably one of the most important key factors on reliability, because you could be actually designing it well, and you could be testing, analyzing, and you could be doing everything right. And then you take it to manufacturing, and it's possible that the manufacturing would source the components with cheaper components, and they wouldn't even discuss it with you. Why? Because they want to save some money. And then these will be suppliers that either are untested, unqualified, the specification of these components don't meet the testing requirements for, or life requirements for your product. There could be all kinds of things happening. I've seen it firsthand in companies that I worked, where supply chain team actually second sourced some components. And the first source was from Japan, for example, met all the qualifications for specifications, met all the design requirements, and basically went through the tests and reliability tests and assembly to everything perfectly. But then something happened, and the first source couldn't meet all the volumes, and they had to go back with equal specification, drop in replacement, and go with the second source, which was slightly cheaper, but apparently met all the requirements. And guess what happened? All kinds of mayhem broke loose. Either the supplier quality was no good and didn't meet the design requirements, or the designers, while they were designing for this primary source, ended up making it so tight in tolerance and stack ups. Now you put the new part in, it doesn't fit. And so all kinds of things can happen when it comes to manufacturing. And I think that when it comes to manufacturing, that's why the first 30 days is crucial, to make sure that I actually, even before 30 days, first 30 days, there is most companies, if they got the budget, they usually have what they call actual pre-production run. So that means they run about 300 to 500 units in pre-high volume production. And this way they get all the kinks, they get all the bugs out of the production. They fix all the issues. They run small samples of the first source and the second source. They tune up their pick and place machines. So there's a lot goes on in the manufacturing that could affect overall reliability that needs to be ironed out.
Okay. Are there any others that you can add?
Yes, sure. I think some of the other minor things, but equally important, that I think that our listeners keep in mind. One of them is user manual. It is so unbelievable that I've seen this in some of the Chinese products, but Chinese products are really improving a lot. But some of the old Chinese products, or if you get something cheap, you'll see a user manual say, push the button on the right. But because it was translated wrong, and it says the right button is really supposed to mean left button. And then all of a sudden you keep pushing the right button and nothing is happening, or you get in the wrong response and it's not correlating with the user manual. And so that could really turn the customer upside down and make them angry and upset, and you'll have all kinds of returns. People will be returning the product saying, I tried it, I followed the instructions, it didn't work. And that's why it is very important to create a product that not only comes with a quick start guide, but also somebody from the company and engineering, development, and or manufacturing need to actually follow the user guide and do exactly what it says and see if you get in the same reliable results. Not just somebody who wrote that and never tested. And that's one of the problems that I see.
Right. So that's a number of problems that can cause unreliable products, which is absolutely what we want to avoid. So now that we know what to avoid, I think it naturally leads me on to asking you, okay, fine. How do we actually apply design for reliability then? So what kind of methods can you suggest at this point?
Awesome question. I think this is one of the key, basically, I would call secrets of DFR. You're designing a product, and a lot of times you could have good design, good manufacturing, good everything, good testing, but your product is still failing because probably two reasons. Either you designed the product with components that are experiencing high stresses. And so what are you going to do? You must reduce the stress, and then your failures will go down, right? That's one key secret. And the other one is, okay, well, you're seeing a lot of components fail because your components are weak. So what do you need to do? You need to increase the strength of those components so that they can handle more stress, and that would lower your failure rate. So those are the two important things. And there are many techniques in engineering design. One of them is called derating. So, for example, let's say you have a high power resistor, and it's supposed to run at 10 watts. Then what you do is you run it at 5 watts. That way you are basically you have a component that is stronger for what the need is. And if, for example, you run it at 5 watts and something happens and it's running at 6 watts, well, no problem, because you still got plenty of ways before it reaches 10 watts. And even at 10 watts, there might be some marginal reliability. So that component is not going to fail so soon. All right. But if you do exactly the opposite, so you have a component that is rated 5 watts and you run it at 4 watts, well, you're already running it at max capacity almost. And sooner or later, that component is going to fail. So if you can just use these two guidelines, I think and plus follow the best engineering practices on design and selection of the components, analysis of data after testing. I think, and if you have a good quality manufacturing and you're checking your boxes before shipping by ISTA 2A guidelines, and you're making sure that your user manuals are being actually tested to see, 1, 2, 3 on the quick start guide exactly gives you the ideal results that the users should see, then I think you're going to have a reliable product.
Great. Okay. Yeah, those are some cool secrets, and that's definitely something I hope everyone's been taking notes while they've been listening, but
I hope
absolutely. So. Yeah. So once again, I mean, look, yet more reasons to really focus on the reliability of your new product when you're bringing it to market. And I'm sure a lot of the points that you've mentioned, I hope that the listeners already kind of have thought of these, but I'm sure there's been some points in there that are, ringing a bell for people and thinking, oh, actually, yeah, Andrew's got a good point with this. I mustn't forget that. And Andrew, before we finish, this is something that your team are working on almost every day for different customers of ours, right? So can you just tell me a little bit about the process and how we can help?
Yeah, I think that's an excellent question. Well, when we get a new design or basically a new project from our clients, we kind of evaluate the design, and we look into it from all kinds of industry standards on how to design it properly, and follow industry standard design guidelines. But more importantly, when it comes to design for reliability, we think of all those industry standards of, what can we do? How can we design it well, so that it's going to be manufactured well, it's going to be reliable, and so forth. But then we also go through very, compressed part and component selection process, where we actually go and audit our suppliers. We make sure that our suppliers can meet our volume requirements, our quality requirements, our reliability requirements. We see how they build and design and build the components, and we see if those stresses that our product is going to experience, these components can experience. And then when it comes to testing, we actually design, kind of tests that are going to mimic and or simulate realistic, real life scenarios that the end user is going to use this product in. And that's the key, because if you're testing it, like an airplane is being tested, that's not going to work for your product. If your product is a consumer product, then you need to focus on, when my end user customer actually receives this product, he opens the box, how is he going to experience, how is he going to use this product on a day-to-day basis? And so we make sure that we test that product on a worst case conditions in terms of environment and in terms of reliability. And so that we can find those issues now while we're developing and fix those issues. And then our client will never see those issues in the field. And then, of course, when we're testing, we'll do the same thing. We'll do parameter analysis of our data, and then we'll do failure analysis of the data if necessary. We'll do corrective action implementation on each one of those failures. And then we do another round of testing to make sure that those corrective actions are implemented properly. And then same thing in our manufacturing. We have pokeoki in our assembly. We have jigs made that make the assembly semi-automated. In some cases, we have automated process. All of our pick and place machines are all automated as well. And then in the shipping, we always recommend for our clients to run their packages through ISTA 2A testing, so that we get a good confidence level on the reliability of the package and shipping. And then, of course, user manual, we give, if the client already has a user manual, we test the user manual and we give them some feedback on what needs to be improved. So the way we do our processes in Agilian is exactly through the DFR and DFX process.
Excellent. I like all of the best practices you're talking about there. And if anybody listening has any questions or needs any help with product reliability, bearing in mind what you've just said, totally get in touch, right?
Yeah, absolutely. I mean, all you got to do is get in touch with us and let us review your product and give you some feedback. And, maybe that is what you've been looking for.
Okay. Thanks for joining me today, Andrew.
Yeah, Adrian. Thanks a lot. And until next time.
And thanks, everyone, for listening in. We'll be back next week as normal. Thanks again for listening to this podcast, brought to you by the Sofeast Group. We're on a mission to provide you with everything you need to manufacture effectively in Asia, including inspections, auditing, new product development support, contract manufacturing, 3PL warehousing and fulfillment, and much, much more across Asia's key manufacturing areas. Visit us at sofeast.com, that's SOFEAST.com, to learn more and get help. If you've enjoyed the podcast today, please do rate, review and share, because it will really help others discover us too.